In this video I'll be explaining how to derive the translation matrix. Okay, so what I'm going to do is just draw a standard x and y 2D Cartesian axis, and I'm going to define a problem which we have. And so I'm going to take this red point here, which I'm going to say is point A. Okay, so I'm going to give it coordinates ax and ay, and what I want to do is I want to move this point ax, ay along the vector t, so I'll end up at this point up here, which I'm going to call B. So B will have coordinates bx and by. Okay, so we're starting at point A. All I want to do is translate point A along vector t, so I get to this point bx and by. Now, if I define t, the vector t, as a 2 port tx and ty, it's quite easy to see that the coordinates bx is simply ax plus tx, and the coordinate by is ay plus ty. So that's simple enough. And what we want to do, particularly in computer graphics, is to be able to translate a whole set of points, not just an individual point. And we could do that by making use of a translation matrix. So if we have our ax and ay coordinates, okay, so if they are written as homogeneous coordinates, okay, so I'm going to write them as a column vector here. So I've got my ax, my ay, and my third element I'm going to have as 1. Okay, and we've seen that that should be equal, okay, the ax should be equal to ax plus tx. So sorry, that's the bx, that's the coordinate which I'm going to end up at. Okay, just tidy this up a bit. Okay, so that's tx, and the by coordinates I want to be ay plus ty, and I'm also going to have that 1. Okay, so that's what I want to end up with. And what I'm going to do is I'm going to see, or I'm going to need to determine what matrix that we can multiply our a coordinates by. So by a coordinates I mean these coordinates here, to get our b coordinates. Okay, so we're going to have this matrix, and this is going to be a 3 by 3 square matrix. Okay, well, if looking at the first, the ax coordinates to start with. Okay, so I've got lots of ax, so I'm going to have a 1 here. I've got no ay, so I'm going to multiply ay by 0, and I've got lots of tx, so I'm going to multiply 1 by tx. Okay, now looking at the by coordinate, I've got 0 ax, so by that I mean here we don't have ax, we just got an ay. Okay, so I'm going to have 0 times ax, I'm going to have my 1 times my ay, and I'm going to have ty times the 1. Okay, for the final number in our homogeneous coordinates, I've just got 1, so I'm going to have 0 ax, 0 ay, and just 1 times 1. Okay, so that's 0, 0, 1. Okay, and this yellow matrix here, this is called the translation matrix, because it simply translates a set of points along the vector t. Okay, that's in 2D, and it quite naturally follows we can write a 3D version. So in 3D we've got a 4 by 4 matrix, and very similar, but we just add a z component to our vector t. Okay, so 0, 0, 1 tz, and 0, 0, 0, 1. So that's our translation matrix in 3D, so that will be multiplied by 3D coordinates ax, ay, and az. And it's quite easy to remember, it's just the identity matrix with this fourth column, the values in the fourth column being our values from the vector t.